Betelgeuse is a red, supergiant star so enormous that if it replaced our Sun, its outer surface would extend past the orbit of Jupiter. It is extremely large, highly unstable, and nearing the end of its life, soon to explode. Such stellar explosions are among the most powerful bursts of radio energy in the universe, releasing more energy than 1 billion suns combined. Are we ready for what's coming? Betelgeuse, one of the closest massive red supergiant stars to Earth, recently underwent a dramatic dimming that has caught the attention of astronomers and the public worldwide. This unexpected change sparked speculation about what it might mean. Some scientists suggest this dimming could signal an impending supernova, a catastrophic explosion that happens when a star runs out of nuclear fuel and collapses under its own gravity. This potential event worries not only scientists, but also raises questions about how it could affect life on Earth. Betelgeuse is a key star in the constellation Orion, easily spotted in the night sky by its bright, distinctive shape. Also called Alpha Orionis, it's the brightest and largest star in that constellation. NASA's Hubble Space Telescope and other observatories have detected unusual activity in Betelgeuse, including a massive ejection of material in 2009, a rare and unexpected phenomenon for a star of its kind. While our Sun regularly experiences coronal mass ejections, Betelgeuse's behavior adds new insights into the life cycle and dynamics of giant stars. There is still debate about how far away Betelgeuse really is, with estimates ranging but possibly as close as 724 light-years from Earth. Measuring distances to red supergiants like Betelgeuse is challenging due to their size and brightness. Betelgeuse is among the brightest stars visible to us, shining about 100,000 times brighter than the Sun. However, this brightness comes at a cost. It burns its nuclear fuel much faster, accelerating its journey toward death. Eventually, it will exhaust its fuel, causing the star to collapse and likely explode as a supernova. This explosion could leave behind a neutron star, or even a black hole, depending on the details of the collapse. So, does Betelgeuse pose a danger to Earth? If a supernova happened within a few tens of light years, it could be catastrophic. Such an explosion releases an immense amount of light, potentially outshining an entire galaxy. Even though Betelgeuse is relatively distant, like Alpha Centauri, its supernova could still have significant and wide-ranging effects. Since the last supernova observed in our galaxy in 1604, humanity hasn't witnessed such an event nearby. The most recent notable supernova was in 1987, in the Large Magellanic Cloud, about 169,000 light-years away. While it was impactful scientifically, it posed no threat to Earth, reminding us how enormous and powerful these cosmic events can be. The idea of a danger zone around supernovae is important because such explosions can devastate life on planets close enough. Supernovae can release lethal radiation capable of destroying a planet's protective ozone layer, exposing it to harmful solar radiation long after blast. Recent studies have identified new risks tied to massive stars exploding spectacularly, including extreme bursts of X-ray and gamma radiation. Supernovae can become some of the brightest objects in the universe, sometimes outshining hundreds of billions of stars combined. If Betelgeuse were to explode, it would become the second brightest object in our sky after the Sun, visible even during the day and casting shadows at night. Such a display would be both awe-inspiring and terrifying, revealing the raw power of cosmic forces. However, the visible light is just a small part of the energy released. The more dangerous aspect is the high-energy radiation, X-rays and gamma rays, that could strip away Earth's ozone layer. Without this shield, life on Earth would face intense ultraviolet radiation, which could lead to mass extinctions. Right after supernova, the intense radiation poses immediate risks. Later, cosmic rays, high-speed subatomic particles, flood the solar system, causing further damage. These cosmic rays can continue harming the ozone layer and bombard Earth with radiation for centuries. Geological evidence, such as elevated levels of radioactive isotopes like iron, 60 found in ocean sediments and lunar soil, suggests Earth may have been affected by supernova ejecta millions of years ago. Currently, no nearby supernova candidates threaten Earth imminently, but ongoing research shows some types of supernovae surrounded by dense disks of material could emit intense, long-range X-rays. potentially depleting a planet's ozone layer by as much as 50% within 150 light-years, enough to cause extinction-level events. Fortunately, no such X-ray supernova candidates are close to us at the moment. These findings have also refined our understanding of the galactic habitable zone, the part of galaxies where conditions support life. While the outer regions don't produce enough heavy elements to form rocky planets, the inner regions face higher risks from frequent star deaths. In summary, Betelgeuse's recent dimming and unique behaviors have heightened awareness of the life cycles of massive stars and the cosmic risks they may pose. Though the star is likely too distant to threaten us imminently, its eventual supernova will be a spectacular and scientifically invaluable event that will remind us of the dynamic and sometimes dangerous nature of our universe. Frequent supernova explosions in certain regions can irradiate the surrounding space, increasing the risk for any potential life that might exist there. Recent research suggests that the inner edge of the galactic habitable zone is likely farther from the galactic core than previously believed, reshaping our understanding of where life could potentially thrive. So, what will the Betelgeuse supernova look like from Earth? While it's reassuring that Earth's biosphere will probably remain unaffected, the event itself will be impossible to miss. Experts predict that Betelgeuse will shine brightly for more than 3 months after its explosion, reaching a luminosity comparable to about half that of the Moon, roughly 9 times dimmer than a full moon. Essentially, it will appear as a brilliant point of light in the sky, visible even during the day, captivating observers and casting shadows at night. This cosmic spectacle will surely fascinate people worldwide, as the supernova remains visible to the naked eye for several years, gradually fading over time. As scientists continue studying Betelgeuse, they are learning more about the life cycle of massive stars and the processes leading to their explosive ends. During a supernova, not only is intense light emitted, but heavy elements such as gold, silver, and uranium are also formed under extreme heat and pressure, a process called nucleosynthesis. This is essential for enriching the interstellar medium with the building blocks needed for the formation of new stars and planets. Interestingly, the remnants of supernova, known as supernova remnants, can become stellar nurseries, where new stars are born from the dust and gas expelled during the explosion. This cycle highlights the interconnectedness of cosmic events. The death of one star can lead to the birth of others. Researchers have identified many such remnants, still creating new stars millions of years after the original explosion, showcasing the universe's dynamic nature. Supernovae also serve as important cosmic distance markers. Astronomers use Type Ia supernovae, explosions of white dwarf stars with consistent peak brightness, as standard candles to measure vast distances in the universe. This method has been crucial in understanding cosmic expansion and led to the discovery of dark energy, the mysterious force accelerating the universe's growth. Furthermore, studying supernovae provides insights into the potential habitability of exoplanets. Researchers are investigating how radiation from these stellar explosions might affect planets orbiting nearby stars, potentially influencing their atmospheres and the chances of supporting life. This underscores the importance of understanding environmental factors that govern life across the cosmos. The prospect of witnessing a nearby supernova also raises intriguing cultural questions. Throughout history, supernovae have inspired myths, legends, and artistic expression. Such explosions are not just scientific events. They hold powerful symbolic meaning, representing transformation, destruction, and rebirth. In many cultures, the appearance of a bright new star in the night sky was seen as an omen or cosmic message. Advances in technology have dramatically enhanced our ability to detect and study supernovae. Space telescopes with sophisticated sensors capture detailed images and spectra, revealing their composition and behavior, while ground-based observatories monitor these transient events, enabling rapid response and real-time data collection. The future of supernova research is full of promise. With new instruments like the James Webb Space Telescope, scientists will gain unprecedented insights into the life cycles of stars and the intricate dynamics of these spectacular cosmic phenomena. The explosive deaths of stars like Betelgeuse offer valuable insights that could revolutionize our understanding of stellar evolution and the fundamental forces shaping the universe. In essence, Studying Betelgeuse's impending supernova opens a door to wider discussions about the life cycles of stars, cosmic recycling, and how these dramatic events influence both life and culture. Examining such massive stars deepens our appreciation for the complex and often violent processes that govern the cosmos, shedding light on our place within this vast and ever-evolving universe. Supernovae are pivotal milestones in the cosmic timeline, marking the death of stars and leading to the creation of diverse celestial structures. For example, the remnants they leave behind can develop into nebulae, immense clouds of gas and dust that become fertile nurseries for new stars. These nebulae also host intricate chemical reactions, fostering the formation of organic molecules that serve as the building blocks of life. Additionally, the shock waves from supernova explosions can stimulate star formation in nearby molecular clouds, a phenomenon known as triggered star formation. This process highlights the interconnected nature of stellar events, showing how a single explosive death can spark the birth of new stars and planetary systems. This underscores supernovae not only as a final act in a star's life, but also as powerful catalysts for ongoing cosmic evolution. On a grand scale, supernovae contribute to spreading heavy elements across the universe. These elements enrich the material from which new stars and planets form, shaping the chemical diversity essential for life. This cosmic recycling emphasizes why understanding supernovae is crucial, not only for astrophysics, but also for uncovering the origins of the elements that compose our planet and, ultimately, life itself.